Man has always dreamt of flying like a bird. But liftoff was not as easy as it looked. 11th century Benedictine monk Almar reportedly strapped wings to his back and launched himself off Malmesbury Abbey. But he glided out of control to come to a painful landing. In 18th century Paris, the Montgolfier brothers, noticing that hot air made a paper bag rise, built a hot air balloon and made history with the first ever lighter-than-air manned flight.
Oh, très bien, magnifique.
Although their design did have its drawbacks. But for a flying machine heavier than air to take off and remain airborne, engineers would have to learn how to harness the forces of nature. This would remain an impossible dream. Until, in 1804, British scientist Sir George Cayley closely observed birds and finally unlocked the mystery of flight, earning him the title, the Father of Aeronautics. Cayley discovered that in flight, a bird's wing has a curved shape known as an aerofoil. Air passing over the curved surface speeds up, losing pressure. The pressure of the undisturbed air below remains high, and so creates upward force. Cayley built a whirling arm to test his theories. By turning the aerofoil upside down, aerospace engineer Dr. Ben Evans can demonstrate how this shape can successfully conquer the forces of gravity.
Now, in this experiment, on one side we've got weights representing gravity, the force that needs to be overcome, and on the other end, an aerofoil. And as this spins, the arm goes level. The air passes over the aerofoil and pulls it down to counteract gravity, which is what lift is trying to do in an aircraft, only upside down.
In 1853, at the age of 79, Cayley put these ideas into practice and launched the world's first heavier-than-air manned glider. Sir George Cayley had made the impossible possible.
It's amazing what you get it to do when you know how.
Cayley's achievements have inspired generations of aerospace engineers to reach for the skies.
By doing some very simple experiments, he managed to show what allows a wing to generate lift, just like the wing of this glider that is allowing us to hang here in the skies.
By the late 1800s, aviation pioneers recognized the need for power and thrust to obtain flight. In 1874, Frenchman Félix du Temple attached a steam engine to a monoplane.
Et voilà!
But the weight was all too much.
Sacré bleu!
In 1903, American professor Samuel Langley built a giant catapult to aid launch. But the takeoff didn't go as planned. Luckily, two siblings from Dayton, Ohio, were about to make one of aviation's most significant breakthroughs. In December 1903, Wilbur and Orville Wright launched the maiden flight of the Wright Flyer. Two propellers driven by a piston engine gave the plane enough thrust to take to the air. Although only lasting 12 seconds, covering 36 meters, it was the first controlled powered flight and heralded the birth of modern aviation. However, more than a century on, getting a plane more than 1,500 times heavier than the Wright Flyer airborne would be impossible without a remarkable British innovator. Up until the late 1930s, piston-engine propeller planes had been the aviation standard, but they were limited in range, speed and altitude. A radical solution was required.
What an incredible sensation!
Aerospace engineer Dr. Ben Evans is experiencing firsthand the power of the Gloucester Meteor, Britain's first ever jet fighter, and impossible without the genius of a British engineer. Frank Whittle, pioneer of the turbojet.
I can feel the acceleration pushing me back into my seat. And these two engines kick into work either side of the aircraft. You feeling okay? Yeah, good.
Whittle's new engines were powerful enough to carry the Gloucester Meteor vast distances at 12,000 metres high and at almost 1,000 kilometres per hour.
This was a leap forward in terms of the possibilities of what aircraft would be capable of doing.
As effective as it was, the concept behind the engineering was deceptively simple.
In essence, the way the jet engine works is you have suck, squeeze, bang, blow. You suck air in at the front here, and then that passes through a spinning compressor. And that compressor squeezes the air down, increases the pressure and the temperature of the air before it passes in to the combustion chamber. Now, this is the point where the fuel is added and ignited. This increases the temperature and the pressure of the gas even further. And then all of those hot exhaust gases have to expand, speed up through the back of the engine, and they pass through this turbine. And the turbine is connected via a shaft down the centre of the engine to the compressor at the front, making that spin. But what pushes the engine forward, what generates the thrust, is the expansion and the acceleration of the exhaust gases out of the nozzle at the back of the engine.
Whittle's turbojet allowed aircraft to fly faster, higher, and further, and changed the face of aviation forever.